Hey everybody, I'm David.
I'm Michael.
And we're from OutsiderTurtleHorderbubble.com.
No. We turned that off.
We did?
Yeah.
Oh, we turned it off. Anyways, it's just David and Michael time.
Yep.
On Outside Our Bubble, streaming on our channel, obviously.
Yep.
And I hope this is coming through okay. Please give us a thumbs up if everything looks great. Let us know. Chat session is live. Brenda's monitoring it, and she will post our questions to the board. We will try to answer them along the way.
Yeah, we're going to be busy here. So
we are going to be busy because we have a time crunch. We have to shut the coach down in order to do this. And basically,
maybe we want to start by telling people what we're doing.
Well, yeah, we want. Yeah, good. Hey, first off, we're live. Look at that.
In person.
We're not. Michael's not in Vegas, and I'm not in New York. Michael is in New York. I'm in New York, and we are live. And finally, I've been talking about this for a freaking year. We're going to be changing these battery packs out, which are way overdue, are they not?
Yeah, they drop from like 13.6 volts when you kill power to like 12.0 in about 15 minutes.
Yeah, they're
really
not good, not good at all. So
that's with zero load as well, not much load.
Yeah, and the refrigerator cooks on, forget about it. I was at the point, Brendan and I, when we stopped overnight traveling, I would actually have to turn off the refrigerator overnight just so we didn't discharge.
Yep.
So, in any case, it's been a long process. We've been researching a lot of batteries, right, Michael?
Absolutely.
I mean, not only I, but Michael has been, obviously, my techie bud. I mean, we talk about a lot of stuff. And I almost said the bad word, but I didn't. In any case, we talk about a lot of stuff, and batteries was one of them. And Michael, as you know, if you recall from turtleherding.com, you can go there and see it. Michael actually uses Tesla battery packs in his motor coach.
And my car hauler. And my astronomy shed, and I still have another 5 that I haven't installed yet.
But see, we're not that extreme. Brenda and I, we're mellow, as you will, if you will. So we've been researching batteries for a while, and I've been trying to work with Donald, and I'm going to just say it. I mean, it's worthwhile. It's taken us this long. I've needed battery packs for a long time. These batteries are the original from 2014 when the coach was built. And they're AGM Lifeline batteries.
And so they're quality batteries.
Yeah, they're very quality batteries,
high end. They've been a little too long in the basket.
Yeah, they've been used a little bit too much. Exactly, yeah. So we've been looking for batteries for a very long time. We're not looking, but researching. And I've been, as you know, I work with Donald from EEZ RV Products. And Donald has been trying different battery packs. He's trying to find the right mix for price point and battery cells to bring to the RV market. And quite literally, I just ran out of time with Donald. And he's trying to do it right. Yep. So that's all I can say about that. I just ran out of time.
Yeah, and we needed time where we overlapped.
Yes.
And we kept missing each other.
We did.
Had plans, the pandemic, and all that stuff. I mean, it's just been tough to get together for a long time.
But all in our research, we've had a number of people, a number of companies reach out to us, me and Michael, in regards to, hey, why don't you use these batteries? And we've actually had companies offer us batteries, which I turned down flatly because that's not what we do. But in our research, we finally made a choice.
Well, you made the choice.
Well, yeah, I made my money. It's my money.
I tried to talk him into Tesla batteries, but he wouldn't.
He did. He tried to talk me into.
He didn't want to swap his inverters.
He tried to. Yes. I was not going to switch over to 24 volt and all that to go with it. So we needed to make this easy and make it workable. And we did a lot of research, and there's a lot of companies that make batteries for RVs at this point. But along with Michael's input, however, agreed?
Sure, absolutely.
Okay, just don't want to put words in your mouth. You know,
yeah.
He's bigger than me, so I got to be careful. Like, Anyways.
Yeah, so there's a few contenders in the RV drop-in replacement market.
Yes, sir.
That are commonplace names, right? There's Battleborn, which
that's the
everyone
biggest
knows.
Name. Everybody knows the name.
They're in a lot of RVer or YouTube RVers. They do a lot of sponsors, a lot of public outreach through the YouTube marketing channels.
They do, and they've reached out to us.
And they're great. They even now have heated batteries.
They do.
So you can run them in cooler environments, colder environments.
And that's important.
And they have larger capacity formats now as well.
And different size and configurations, which is important. And that's one of the reasons the batteries we chose, because my shelf these are Lifeline batteries, okay?
Yep.
These are high-end Lifeline batteries. That's right there, what you're seeing behind us is I think you can see that.
Yeah.
Yeah, is 900 amp hours of battery power. And that's AGM batteries. So those are 90 pounds a piece, each battery.
Yeah, we're going to be hefting those out here in a minute.
Yeah. So in any case, oh, that's the one thing I did forget. Of all the tools I had to get ready, you said make sure you get all the tools ready, Dave.
Yep.
All the tools, I forgot to get the cutters.
I've got
Anyways,
cutters.
no problem. We got them ready. So, anyways, we researched and I played with different batteries. I talked to different companies. I did different things. Like I said, Battleborn was one of them. They reached out, but as you know, we want to do what I thought was right, and its price point is important to us, and also is functionality.
And cold temperature operation.
And that's what I meant by functionality.
Yes.
So good lead in there, Michael.
And format, the size
The
to actually fit well
yeah,
and get the maximum capacity in this tray.
Yeah, in order to fit this tray, I needed a special battery format that would fit that tray, which is you know, not an easy task sometimes.
Yep.
You would think all batteries are the same size footprint, and they're not. So you got to be careful that you get the right size battery footprint to fit your trays. Now, let's go back to the battery type and the heated format, if you will.
Sure. So the common way that most heated batteries operate is they take power.
Well, before you go there, hang
Okay.
on. I'm so sorry. I have to
It's all
interrupt
good.
my buddy. You first need to explain why.
Right. Okay. So lithium-ion batteries, depending on the chemistry, they have a certain temperature below which you should not charge them. Charging them below that temperature causes permanent degradation of the battery. You may be able to continue using it at a reduced capacity, but it's permanent, irreversible.
It's going to
damage
kill your battery.
to the battery.
More or less.
Yeah, depending on how aggressive you are with the charge or how cold it really is. And keep in mind too that these specs for the low temperature are based on the internal cell temperature, not the outside temperature.
Not the outside temperature of the coach and the battery. Yep. It's the internal cell temperature of the battery itself.
Yeah.
So you could be in a heated compartment and you'd be just fine. Don't
Yep.
get us wrong.
Or you may have just a cold snap overnight that, you know, drops below that temperature, but the batteries actually never reach that cold of a temperature because it doesn't stay cold enough long enough.
Let's face it, they're dense as it is.
Yes.
So yeah, so that's exactly it. However, because recently, like last year, we were in Houston, Texas, and it got down to below 20 degrees for 4 days straight where we were. Well, because of that, and they added the fact that Houston lost power, we had no power but the generator, and our batteries weren't doing that great, as we mentioned. Yep. So if we had lithium-ion batteries that did not have a heating function, we wouldn't even be able to charge the batteries correctly. So it's very, very important that you have a battery, if you use lithium ion, that they are above 32 degrees. 32 degrees or above, or whatever.
Well, yeah, depends on the chemistry. But yeah,
yes.
For, I think for lithium iron phosphate, it might be a little lower, but yeah, just check with the manufacturer for the spec, what temperature you should not be charging below. Make sure you don't do that unless it's, I mean, and if you're in dire straits, you got to do what you got to do, but just know that you're going to be damaging the batteries.
And that all comes down to a proper BMS, a battery management system.
Yeah, so there's a lot of
aftermarket batteries.
Let's say non-name brand.
Non-name brand batteries.
Not
I like
recognizable
that.
lithium-ion battery brands out there that they have a BMS, battery management system, on board. And it may do a high current or a high voltage or low voltage cutoff, but it may or may not have a temperature cutoff. And if you don't have a low temperature cutoff, you may end up being able to damage your cells. Whereas if you had a BMS that had a low temperature cutoff, which realistically all should, but most don't, or many don't, then it would protect you from yourself. So you got to know a little bit about what you're doing going into it so that you don't damage the investment that you put into the lithium-ion batteries.
So that was
not cheap.
Yeah, no, not cheap. And that was one of the big things that when we were researching different batteries, and we researched a number of different batteries that made us lead to the battery we chose. And the battery we chose is a battery that we're going to reveal here, obviously. I paid fully for these batteries. I got nothing for the company. Want to state that fully. Now, I did not ask, nor did I receive anything except for support when I asked for specific information about the battery. I got support.
Just like anybody else.
Yeah, if you would.
Yeah.
Yeah. So.
And so back to the actual heating conversation.
Yes. I'm sorry.
So some batteries now are coming with the ability to heat
the
battery itself
beforehand.
Yes. And so I think the first one that did it was a company called Xantrex. And if you watch the RV Geeks, they provided them with a Xantrex heated battery.
They gave them a battery system.
The downside is, at least last I checked, Xantrex batteries were not available aftermarket. They were designed
only
and
for
only
the
selling
OEMs. That's right.
So that left Battleborn, which now has a heated battery.
Which is great. Battleborns are U.S. made.
Yes, U.S. made. They take a lot of care in how they assemble their batteries and what they put into it. So high quality, good batteries. A little bit higher cost per kilowatt hour.
Yeah, but there's a reason for that. One of the reasons I do believe, and now we're not talking, let's just take the heating part of it aside, because there's a reason I chose the batteries I did, and we'll get back to that in a second. But Battleborn in particular, every one of their cells, if I'm not mistaken, Michael, and you correct me if I'm wrong, which you would anyways. So anyways.
I'm not bashful.
Yeah, Battleborn, they actually take the time and the cost to check every cell that they produce, and they rate every cell. So they're matched. When they put them into the packs, they are matched cells in regards to capacity wise and what have you.
Yep. So that's really important, and we'll get to our experiences here in a minute.
Yeah.
So yeah, Battleborn really is kind of the premier drop-in replacement. And their parent, or their OEM side, Dragonfly, I think is the name of it.
Yes.
They provide OEM lithium-ion batteries. Battleborn is their aftermarket brand version. They're both the same cells, both the same manufacturing process. So back to the heated part for just a minute.
Yep.
With to our knowledge, and we could be proven wrong, but to our knowledge,
and they might have changed it for all we know too.
They may have changed it. Most heated batteries heat from the battery power, so it will actually drop the charge of the battery while it's self-heating, so that you can then put charge back into it. The other way of doing this, which we didn't even know someone was doing it this way
until somebody reached out to us.
Yeah.
We were doing a live drive and we talked about it, and somebody reached out to me about this.
Yep. And I think actually they commented on the lithium-ion battery talk we did some months back.
Yes, exactly.
So they commented, and we did some research and found out that, again, to the best of our knowledge, this is accurate. This particular manufacturer takes the charge current coming into the battery to preheat the battery before it starts charging the battery.
Yes.
Or at least make sure that it's up to...
And that's important, because if you're taking the charge from the battery to heat the battery up to a point where you can safely charge the battery without hurting it, you could be draining the battery to a point you might not even be able to start your generator.
Yep.
So, this battery in particular...
Or you may hit a low voltage cutoff.
True.
Low battery cutoff on the battery itself, and then you can't heat
You got nothing at all.
And you got to wait for the ambient to come up.
Yep. So this battery in particular, from what we are understanding from our research, is that this battery uses it from the charge side. So basically, if it's below 32 degrees, if you will, just using a number, the battery will actually heat up first. The charging current will come in, it'll charge, the battery management system will heat the battery using the charging current, not the battery current, to heat the battery up to the point where it is safe to then start charging the battery, and it will switch over and start charging the battery. So that's a very important distinction.
Yeah, and it's a great idea. It's a great concept, and it helps prevent those situations where you're at a low battery cutoff voltage and you can't then heat the battery to be able to charge it back up.
Right.
So
now price point also becomes a factor. Lithium ions, as a lot of you know, if you looked into them, they're not cheap for the most part. However, in this particular case, I say however, but because I bought them in 200 amp hour packs, I bought 3 batteries, 200 amp hours per pack, and the cost comes down to about $800 per 100 amp hour.
Yes.
For a heated battery.
Yes.
For a heated battery. So there's a difference.
The non-heated version of this particular battery is less expensive than that.
$90 less.
Per battery.
Per battery. So basically, $90. If you're going to be spending the money on lithium ion, get yourself, in my opinion, because we've been in Houston, Texas, and cold temperatures, and we would have needed those batteries to be heated.
Yes.
But in any case, so without further ado, the batteries that I have chosen, per lots of research and what have you, and also input, we've talked to the company, things like that. LifeBlue. So
Yep.
we are going from
Lifeline
batteries, which are a high-end AGM battery, to LifeBlue batteries.
Yep.
Now this LifeBlue battery is a 200 amp hour pack as I hold it here in my hands at 50 something pounds. Fun.
You want me to hold one side?
I'm good right now.
Okay.
Any case, so
This is what we're going to be installing.
this is what we're going to be installing.
And to prevent David from getting a hernia, I'm going to let him set them down, and
So,
we'll continue to talk
yeah.
a little bit more about them.
LifeBlue batteries are the ones that do the
Heating from the charge.
heating from the charge side.
Yeah.
They're 200 amp hours each, and the other reason we chose LifeBlue, one of the important factors is three of them will fit my tray with no issue whatsoever,
Yep.
which is important.
So it allowed them to maximize the capacity in the tray that you had. For me, I took the tray out, and actually all the electronics down the side, I took all that
Yeah,
stuff
he
out
ripped
and
it all
rebuilt
out.
the whole thing. David didn't want to go that
No,
far.
no.
He'd like to keep using his tray, so
Yeah.
this allowed him to maximize the amount of storage, power storage, in the slide-out tray that he already had.
Does that make sense? I mean,
I hope so.
I hope it does. I
Yeah.
mean, we're trying to give you the details of why I chose the battery I chose.
Yep.
And I will say that straight up front, we did have one of the things you have to do when you get the batteries, all lithium ion batteries, when they're shipped to you, have to be shipped at 50% or less of charge.
Roughly, yeah.
Roughly. Yeah, that's like a shipping law, whatever.
Well, there's shipping law, and then there's also
Whatever they call it.
the longevity of the battery. If you're going to be storing lithium ion, they store best at about 50% charge.
Yep.
So you know that's the way they're stored in the warehouse. That's the way they get shipped to you. So
the first thing you have to do is you have to balance the batteries individually.
yeah, charge the batteries up to what? If you're familiar with battery technology, it's called a top balance.
Top balance.
So it brings the voltage up to the top of what the battery is permitting, and then you do those on each battery individually, so that you don't, when you connect, you don't have this huge rush of current going from one battery to the other. Not that it would damage anything, but if it's high enough, the BMS will kick it out. It'll stop you
just
from
stop
doing
the
it.
charge completely.
Yep. So you do need to charge each individually to get it up to that top balance location. And then once they're all top balance, then you can connect them together. Now, we were lucky in that I had a leftover Magnum inverter.
Yes. I don't know if
yeah, we'll do.
Okay, you didn't get that time.
No, I didn't
okay.
get that set up yet.
Oh well, we have pictures and stuff to show you. We basically took the time to use a full Magnum inverter that Michael had left over from his Tesla install, and we used that to do the top offs. So we topped off each battery individually as per the documentation. And I will say that I was a little dismayed to find that there's 4 packs in there that you look at, and one of the packs was 300 millivolts
cell groups.
lower than the other 3 packs. And what happened was, because of that, when the other packs charged up, they hit 3,600 millivolts, and basically the battery management system protection kicked in. You don't want to overcharge the battery, obviously, and it cut the charging altogether, and it cuts the charging to all the packs. The packs inside the battery, not each individual battery.
I'm going to insert just that little clip here so
Yeah.
you can see it. You can't see us right this second,
It's okay.
but that's the Magnum inverter that I had, and we had it hooked up. In this particular shot, we were topping up the remote or the furthest battery pack.
Yep, at the time.
At that time.
That's the photo
Yep.
that I used in the insert of the show to go live.
Yep.
And so basically we used a high-end inverter, but then once we found out that the cells, the packs, were not fully charging because we had high voltage on one of the cells, we ended up
We
quite
took
literally
aggressive measures.
We did, and like it or not, the manufacturer may or may not like it, but we opened up the pack. Now, the good news about opening up the pack is we can tell you these are really well-built batteries.
Yep.
I mean,
here's a shot of the interior. if you notice, there's little alligator clips up here at the top.
That's us
there's
trickle
black and
charging.
red. Yeah, we're actually topping up an individual cell group in order to get the cells to be more balanced so that they take a charge at the rated battery voltage for the entire battery without tripping the high voltage disconnect.
Yeah, the more they're charging equally, the better off we are. If they hit 3600 or they're close by, whatever their BMS kicks in, it will shut down the charging for all the cell packs. So we were trying to bring up, in this particular case, cell pack 2 to bring it up higher. Now, we don't expect you guys to do that.
No.
This is extreme. We admit this, okay? We totally admit this is far beyond whatever you guys should be doing.
But yeah, so and here's the drawback. If you do not have matched cells and they're not charging equally across all 4 or however many you have in series packs inside the battery, the risk is that you're losing some capacity. Now, it may be very minuscule. In one of the batteries that we topped up, it was extremely minuscule. It was only like 500 milliamp hours, which is nothing compared to 200 amp hours that they're rated for.
Yeah, exactly.
So that particular one, not a big deal. Another one, I think it took like 2.5 amp hours. So compared to 200, you know, you're talking what, 10%?
Yeah.
Or no, 1%.
1%.
So you're talking a 1% degradation of capacity because of the imbalance. Is that a big deal?
Again, are you going to ever notice it? No.
Probably
if you do
not.
not have these also come with a Bluetooth amp. Excuse me, a Bluetooth application that allows you to see the cells. That's how we knew this. For the most part, you would never ever know it.
Yeah. Here's the app we have on screen.
And there's
with
the
high
app right
voltage.
there, and you can see where the high voltage reading was coming in right there. And the reading, if the second cell, you'll see the reading was down to like 33, where the other ones were much higher. And there was a 300-point spread, if I'm not mistaken, if that's the right picture.
Yeah, 300 millivolt. So we've heard some say, and we won't name names.
No.
We've heard some say that that's no big deal.
No big deal.
It doesn't matter if they're matched cells.
Nope.
And to a degree, that's mostly accurate. It depends on how much capacity, how much imbalance there is. We heard that, 300 millivolts, that's normal. I can
That's
tell
not
you,
normal.
No, I can tell you from my lithium-ion batteries, and granted, they are electric vehicle Tesla modules.
So they're high-end battery
high-quality
packs.
modules.
Yeah.
Mine never go beyond 20 millivolts, and that's only maybe for about 5 minutes or so while there's a really aggressive charge or discharge going on, and then they return within 10 millivolts of each other, and I'm talking about 24 cell groups that I can compare those against.
24.
So 300 millivolts, not what we would expect.
No.
But compared, after we've done the self-balancing with a secondary charger and slowly brought it up.
We've actually improved that.
Yeah, we've improved that, and ultimately it wouldn't have really made that much difference.
For the most part, you guys
capacity.
would never notice the difference in the usable capacity over time. We're just us. We're just techies, and we wanted answers. We reached out to the manufacturer. We reached out to the rep and everything. They're more than happy to talk with anybody in regards to stuff, which is great. And so
there's another claim that we should cover that LifeBlue makes.
What was that?
That you can charge them from any alternator without damaging the alternator.
Okay.
Now, let's dissect that a little bit. So that's probably mostly true from any perspective that anyone can measure, with the exception of it may reduce the longevity of the alternator as a part, that it may need to get replaced sooner if you don't have any additional protections in place, like a DC to DC charge controller between the alternator and the batteries. There are videos online. Victron produced one video showing that if you don't do things correctly, you can overheat the alternator and it will melt the little tiny conformal coating insulation in the windings, and that alternator is gone. Now, are you going to do that
Are we going to see it?
No.
No.
That's an extreme case.
Yes,
it's low RPM, so the alternator is not cooling itself very well, and it's a high output. In the situation provided in the video, the batteries were not highly charged, so they were thirsty for power.
They were really driving it hard.
And so but it's something to keep in mind.
Yes. Will I see it in these batteries with my alternator or anything? I don't expect to.
No.
I really don't. With the battery management system, the batteries are mostly going to be topped off all the time anyways.
Yep.
So that the alternator would not have to do a lot of work to charge the batteries.
Yeah.
So basically it looks like a short. If it's a high draw, it looks like a short across the batteries, which the alternator would not like, obviously. But we don't expect that to happen because the battery should be mostly charged as it is.
Most of the time. And when you start your engine, it's not like you're idling for hours on end, letting the alternator sit there and cook itself.
Yes.
So generally, most people may disagree, or some people may disagree with this based on old information, but even Cummins themselves do not recommend idling a diesel engine. It's just not good for it. It builds up soot in the exhaust and turbo system and causes other maintenance woes. It's honestly better just to let the engine sit and not run it than it is to start and let it idle for 30 minutes.
Not like the olden days.
Not like the old days at all.
So in any case.
Yeah.
So these are some of the things that we found out. This is why we chose the LifeBlue batteries. At least I chose the LifeBlue. Mainly how they do the heating off the charge current and not the battery current. I'd hate to get to a point where it's really cold out. We've drained the batteries. The heaters have to kick in to heat the batteries. It drains the batteries down to a point where you can't even start the generator. Then where are you? You're screwed.
Yeah.
So
there is a question
I like
here.
the idea there. So in any case, we're going to really quickly look at the questions here. Michael, if you want to give me a clipper, I want to start this install because that's really what I need to do.
Be careful, those are my nice ones. Actually, let me give you the bad ones.
Give me the bad ones. These are a little small.
I don't want you.
And what I need the clippers for is because they have a lot of twist ties inside of here that you'll see in or not a pull ties. So, and one of the things we also, please be aware when you do this on your own, turn off your internally inside, turn off your inverter, turn off your charger, and also battery disconnect.
Yep.
So we want to make sure we're safe when we do this install. And right now, I have
hooked up a temporary.
I have hooked, I've hooked up a temporary controller, and we have
right now the inverter's still on. So we're going to kill the inverter, and the charger is in charger standby, which means off. So
we're
from
good to
an
go.
inverter perspective, we're okay. And then we're going to drop the house power here in just a second.
So you can go ahead and answer questions while I start to work on the disassembly of the battery packs.
Sounds good. All right. So let's see.
Ouch! Only kidding. Only kidding. You knew that was coming.
I'm gonna change.
You knew that was coming.
Shots here
Come
so
on.
you can see both of us. So the question is, what is the warranty on the new batteries? If you go to LifeBlue Battery or LifeBlue Batteries.
I thought they were.
Oh,
60,
battery singular.
I thought they were 60 months.
It sounds right. I think it's 5 years. And then beyond that, between 5 and 10 years, I think there's a prorate based on the remaining capacity. Don't quote us on that though.
Hey.
Go to lifebluebattery.com. There's a documents section, and in that document section, they have a warranty details there.
Am I visible?
You
by
are.
The way? Am I visible? Where's the camera view?
We've got the wide shot there of you.
Hi. Okay. So yeah, I will say, I have to say, LifeBlue's been great in contacting them and talking with them in regards to different things. So they're, I give them kudos, for customer relations kind of thing. But we were talking about the warranty part, and I don't foresee any issues warranty wise.
No, I don't.
So
the warranty is decent. It's comparable to anything else out there, ballpark.
Okay, one of the things you got questions you're still answering?
Nope.
Okay, so one of the things, they can see this battery pack here?
Yes.
Okay, great, thank you. Hey, one of the things that we will not need when you're switching over from these are AGM batteries, by the way, is we will not need a temperature sensor because that's all going to be built into the battery management system. So right here, the Magnum temperature sensor will no longer be used. That'll be disconnected. And Tiffin, for whatever reason, they use this thing called a power pulse maintenance system. This is something else that would not be used. So none of these will be put back in. So just a note on that. So don't say, hey, you forgot to put those things back in the comments, because we didn't. We know they're not supposed to be put back in. So now, before I start disconnecting these terminals, I am actually going to do a battery cutoff on the on the batteries themselves. And there's a house battery cutoff, which is right over here on the Tiffin. You can't see that. Just believe what I'm doing, and I'm going to turn that dial now. So I've just cut all the 12-volt power to the coach itself. It's all gone at this point. We've already turned off the inverter, which you saw. We already turned off the charger, which you had seen. And now we have turned off the battery bank itself.
Hey, we lost power.
What, love?
We lost power.
Oh, yeah, we lost power. It's because I turned it all off. We're changing the batteries, love. No, that wasn't planned at all, was it? Any case, so we're going to move forward now and put in these. Going to go from Lifeline, which is a great battery, great battery. They've lasted us all these years. 2014 coach. We're now into July, end of July 2021, and these have been good. We've needed batteries for about a year though. And now we're going with LifeBlue, which has a nice little Bluetooth interface. Oh, Michael, you want to talk a little bit about that stuff?
Yeah, so actually I just want to address a comment here. It says,
yeah.
Would it be easier to put the slide out in first?
Yeah, it would. I totally agree. Yes, I totally agree.
But we didn't want to inconvenience Loki. Loki likes his space inside.
Yeah, exactly. Good point. I've already pre-released the battery holders, which we will reuse by flipping them over.
Yep, at least one of them.
At least just one of them to hold the batteries down. So I've already pre-done those. So now we're gonna go on and start removing all of the lugs.
Go ahead. Going back to the LifeBlues, there's an on battery charge indicator. You press a button and it lights up some LEDs.
Yes.
So that's nice.
Yes.
They also have a Bluetooth interface to be able to pull up an app on your phone, and you can see the voltage, the amount of current coming in and out. You can see individual cell voltages, and you can actually rename the batteries so that when you're looking at them in the app, it tells you which battery you're looking at if you want to name them.
Which, by the way, is the way we discovered the cell imbalance.
Yeah. So.
Now, be aware, just putting it out there, guys and ladies who are watching, we did offer LifeBlue, the company, to be online with us today if they wanted to answer any questions live. Again, we are not getting paid to do this. I bought these batteries.
Yeah, so we have a question. Tom Smith asks, if I'm running the batteries overnight and then start the engine to drive off, would it be too large a draw on the alternator? No. So generally speaking, you're going to start up the coach, you're going to bring the slides in or whatever it is you need to do that requires the engine to be on, and then you're going to be on the road. So generally speaking, again, you're not going to be idling for hours before you get on the road with batteries that are almost completely dead. That's really kind of the danger scenario where the alternator could overheat and cause quick damage. So I would not be concerned with that scenario, Tom. So yeah, I think you'll be fine on that.
Now, one of the things we will have to do when we're done here is not only remove these 90-pound each batteries, but we will have to end up cutting this cable right here and the red cable in order to put new ends on. Why is that, Michael?
Because they're
Tiffin.
The bolt opening on the existing terminals supplied from Tiffin is actually a little too large, and that's generally not a big concern, but if you're doing a high current application like these batteries are, then the risk is, or the ideal thing is you want the hole in the terminal to match the bolt size going through it so that you get the maximum connection to the terminal from the battery, so you get the best current transfer capacity.
Yeah, what he said. So I'm just going through and removing all these terminal connections, these little leads that link all these batteries together. And
yeah, so we
made cables already. We pre-made jumper cables to go between the new LifeBlue batteries. Oh, yeah, by the way, speaking of the LifeBlue batteries and cables, Michael, one of the other features of the LifeBlue batteries is they have a communications port, correct?
Indeed. So
for those of you,
because if you're a little geeky, you may want to be able to actually monitor the performance of the batteries in a logged format, so that you can go back and compare performance over time. see what your maximum and minimum voltages were for, let's say, a given boondocking session or something like that. So the LifeBlue actually have, it's an RJ45 port, so it looks like a network cable port. And that port has 3 pins that you would use. 1 pin is ground, because you always want to have a common ground. And then the other 2 pins are what's called an RS485 signal. So if you have Magnum inverters and you have a remote connected and maybe some other accessories like the battery management or battery monitoring kit, that is all RS485 communications as well, but you can't plug the LifeBlues into the Magnums, at least not directly. I think they're working on some OEM interfaces. I think they mentioned working on some Victron Energy interface. But as of right now, that's not available. They're also, if I understand correctly, working on a Wi-Fi module to be able to plug into the batteries so that you can have your battery information on your Wi-Fi. I don't know what that app is going to look like, if it's going to be web-based or how that data is going to come and go, but if you if you are geeky like us, we're gonna I'm gonna write our own interface into it.
And that's what one of the things is. We also, like I said, we did open up the batteries, and we're very impressed by the battery management system boards. I mean, right down to, I mean, they used waterproof coating across the entire boards.
Conformal coating.
Conformal coating across all the boards. I mean, they really did. And the cables they used internally were quality cables too.
Yep.
So
we have another question here.
Go ahead.
Will you just be able to change the existing charger to a lithium profile? So these Magnum inverters that we have don't have an exact lithium profile, but we are able to accommodate lithium batteries with one of 2 profiles based on this specific battery's needs. So one is the custom profile where you can set an absorption and a float and equalize voltages. The other is called constant current, constant voltage. And you'll see that abbreviated in the menus as CC/CV. That's actually the profile we're going to use for David's batteries, and we'll get into that programming here in a little bit.
Not much to it. But yeah, we one of the neat things when we opened up the battery pack, like I said, much to the dismay of the manufacturer, I bet, but we were very impressed by the build quality internally of the battery itself. And we happen to notice there's a CAN bus on board. There's a CAN bus chip. Is that CAN bus chip active at this point? Not 100% sure.
It's sending synchronization pulses, but we didn't get any data out of it. We probably would have needed to send a command to it. Here, David, do you want to take that up? Yeah,
I was going to say we got these ends now. These are the ends that go to the coach. So these are the working ends of the battery. And what we're going to do is we're just going to tape off
the positive,
because Michael's going to cut we're going to cut these and put new ends on them. But just for safety's sake, right now we're just going to put a cover over the positive while we try to remove these batteries from the system here, because now we have to do some leg work.
We have another question here.
Okay.
From Red Jag 100 Travels. Hey, Red Jag.
Hey, Red Jag.
So it says, hey guys, I thought that the new batteries were better installed inside the RV for better protection from weather and temperature change. So generally speaking, it would be great if you could install them in a climate controlled, cargo bay or inside under your bed or something like that. But David chose to buy the LifeBlue batteries that are designed for low temperature operation. And that means they have a self-heating capacity that heat themselves off of the charge power coming into the battery. So it's not going to discharge the battery to keep itself warm. It's actually going to take the charge power coming in, heat itself up, and then once it clears the critical temperature threshold, it'll start charging the battery. So LifeBlue, they thought of this.
Now, if you guys are watching me do this, just so you know, I'm just removing these. I'm going to put these are the stanchions or the screws bolts, whatever, that hold the batteries in place so they don't move. I'm just removing them now. We will put them back later at the end of the, after we're done with the show.
Yep.
But now it's the fun part.
Yeah, you want me to hop in there?
Oh, we're gonna both have to do that. So I just removed all of these cables. These are all the cables that tied back these 6 batteries together. We're gonna be going from all of this to
just 4
interconnects. Plus of course the battery cables to the coach.
Yep.
Okay, so now the fun part is these.
Here, I'll let you slide out and I'll get the first couple if you want.
These are 90 pounds a piece, which are just like freaking amazing. You ready? 90 pounds, here we go. Okay, there's one. Hey, I should also have fuel economy savings too.
Yes, because the new batteries are considerably lighter.
Yes. And that goes the same for all LiPo batteries. There we go. I think it's funny we're going from Lifeline to LifeBlue. So here we go. This is fun, huh, guys?
These are definitely not light.
They're definitely not light, is right. Got to make sure the thing is in the right position, or else you could hurt yourself. Yeah, these are not light.
What is it? Lift with your back? Is that right?
I don't know. I'm just lifting at this point. 70. Okay, look at that. Now we got a nice clean tray. I don't know if you guys can see that or not.
Clean is maybe a...
Come on, it's a relative word. Who's clean?
Do you have a little foxtail and dustpan maybe, or vacuum?
I got, do I have a vacuum? I do have a vacuum.
Yeah,
but I'd have to go get it, and we didn't bring that out. So I'm just gonna dust off this tray with a microfiber cloth. Any other questions going on right now?
No, all quiet. Everybody's thanked us for our
oh wait, look,
answering so far.
There's an insert. I can just dump the tray.
Oh,
nice. How nice is
Here,
that?
I'll let you step out of the way. I'm going to work on the ends.
Oh, okay. That's the next part.
Yep.
So the next part of this whole process is Michael needs to put in, we need to hydraulically clamp. Now this is something most people will not have tools for, but Michael doing all the work he did on his coach with his Tesla battery modules and his trailer, his tow trailer, Tesla battery modules, blah, blah, blah. He bought himself a hydraulic crimp tool.
Yes.
So he can crimp very big wires with this sucker. And lucky for me, I don't have to buy one.
They've actually gone up in price.
Now, don't get me wrong. Don't get us wrong, I should say. Do you need to use this? Do you need to make your own cables? No. You could use the cables as long as they fit. And if I grab a set of cables here that we took off the Tiffin batteries, and I show you the two.
You can show them in the camera right there. That one's live too.
Okay,
in the top
that's live.
Corner.
So, this is what I took off a Tiffin, and this is the one we made. And the difference being is only the hole size. It doesn't look like it's a big difference, right? It does not. And it
probably would be fine.
It probably would just, yeah, it'd be 100% fine, no issue whatsoever.
But we're perfectionists.
But Michael being Michael, I said just use them. He said, no, let's just do it right. So order these things from Amazon, so I did. And you can see, you know, it's not much of a difference, but it's that much more surface that's going to be touching the battery contacts to give you a better charge point.
Better current carrying.
Yeah. Do you need to do it? No.
Would you mind handing me the hydraulic crimper there?
Yes. And then this is the ever popular hydraulic crimper. I don't know if you can see that.
Yes, you can.
I'm looking. Where? Oh, there it is. Okay. So Michael's got the giant hydraulic crimper. Do you want to hold anything?
Yeah, go ahead.
Yeah. See? Look at that. Let's do it over here so people can see it.
It's a little...
So these are stranded cables, by the way.
Very high strand count for flexibility and current carrying.
And you want to make sure you don't have any coming out. And then you want to put it over the top like that. And then Michael's going to go in there with the hydraulic crimper. Hopefully you guys are seeing this. He's going to line it up, because once you do it, it's it. And we only got 2 left, so he's got to do it right. I'm going to push down on it.
I can't see where I'm at now, so I'll rely on you to position in the clamp.
Oh, great. Figures. Going to rely on me to make sure that we do it right. Okay, right there. So he's going to crimp that down now. And we only have 2 of these because we bought a 10 pack. So if we screw up, it's not a good
There's
thing.
that one.
And look at that, nice and tight and not going anywhere.
So this is actually producing what's called a cold weld, or at least that's the aim of what you're doing. So a cold weld, basically it smashes the conductors together with such force that it essentially recombines them into a solid block of metal. And that gives you the most low resistance conductor connection between those mediums.
Okay.
All right, so I need to strip that one back here.
Okay, here's your next one, buddy.
Thank you.
There's the power wire. We will not be using, again, we will not be using the Magnum temperature sensor. So that's just going to go out of the way at this point. I did not discrimp it. I'm just not going to use it. We're going to disconnect it on the other side. We're just not going to use it. I don't want to cut the, well, there's only one more twist tie there anyways, so I might as well get rid of it, huh?
No, you can leave that one. I would leave that one.
Okay.
We'll just cut that off and
We don't need it, so we're just going to get rid of it.
Yeah, actually, before you cut it, we're going to want to disconnect it on the inverter side because there is.
I believe I already have.
There is voltage going.
The only thing connected to it, the inverter right now, is that thing.
Okay.
I disconnected the accessories.
Okay, cool.
And if not, we'll
find out soon.
We'll all die soon.
Nah,
That was quick and easy. No pain involved. Yeah, this is something we do not need at this point, so I just basically cut it off and we'll tuck it away later. Again, we'll just clean up later.
You ready for the next crimp?
We are ready for the next crimp, Michael.
We'll aim for this one to be just a little closer to the shoulder.
Okay.
when we crimp it.
So again, you guys should be able to see this hopefully. I think we're on that view.
Yes, we are.
Okay. Start crimping your arm down. Oh, not my finger.
David is permanently melded.
Wait.
You good?
A little lower?
All
No, that's actually fine. No, let's go. Well,
Let me see. Hang on. Yeah, that's all right. That's all right.
Yeah, that's good. That's fine. Go ahead. I'm pushing down on it a little bit. And I become part of the coach now. There you go.
There we go.
Okay, so now we got our new properly sized.
Okay, David, I think we're live again.
You think so? This is, yeah, that was all me. Of course.
What you missed was David dropped this and it touched this.
Yeah, this is
And
why
if
we
you notice, that's red, that's black. They're not supposed to touchy. So when those made connection, the inverter, which was monitoring for this, it sensed a fault. So it stopped passing power through to David's coach.
and shut the coach down.
Shut the whole coach down. Well, everything that was on the inverter, which happened to be all of his Wi-Fi and all of his networking gear and the outlet out here that all this stuff is plugged into. So, apologies, we went offline for a little bit. You didn't get to see the excitement of us racing around trying to get things reset. Nor did you see David jump when this sparked off.
Oh, I did not jump.
A little bit.
Not
You jumped
much.
A little bit.
I didn't jump much.
So what we're doing right now, getting ready to do, is put this heat shrink over the connection so that this no dirt and grime gets done in there and causes issues in the future. So that's what I'm getting ready to do here.
And just so you know, I cannot seem to get back to the studio.
Okay. So I'm just heating this up and heat shrinking this. It's important to keep things moving while you're heat shrinking because you don't want to burn the heat shrink because it will burn. It's not going to like burst into flame burn, but it will discolor and turn nasty.
Yeah, my internet not coming back online.
Okay, so we got that. Now I'm going to move this ground out of the way, bring that up here, and we'll do that one next. Let's check and make sure we're actually online.
Looks like we're broadcasting according to your display. Lost signal. I cannot, for whatever reason, get back.
Maybe try connecting to the Southwoods Wi-Fi instead. because that should be booted up. So we're just getting David back into his studio. Y'all stop looking at my butt. You're making me self-conscious. Oh, let's see. Where did the black? Okay, so we are online though. Okay, excellent. Good times.
Yeah, I'm not happy about what I just did by accident.
That's all right. It's not the end of the world. Sorry, you got to. This is why live streams are fun.
Especially when you're dealing with voltage. What can go wrong, like I said?
Yeah. All right, now these connections are both covered with heat shrink. All right, so I'm going to lay this far away from the positive. And David, I'm going to start sitting these batteries in.
Okay, I am just pulling our stream back online.
Well, we are online.
Yeah, we lost a lot of people. When we went offline, we lost a lot of people. We went from 75 people all the way down to 12 people.
Okay.
They must have been like, oh, they lost it. It's over. We suck. Yeah, no, don't put those in yet.
No?
Nope.
Oh, you got the tray.
I got the tray right here.
Thank you.
Sorry, buddy. Sorry, buddy.
That's all right.
Okay, now you can put them in.
Now I can put them in.
Yep, and remember we're doing them with the
Comport.
Yep, this way. Boy, man, sorry guys, that was all 100% me, and I just did not look what I was putting that cable, and that was not a good thing.
I'll get it, David.
Yeah, I'm just a little miffed at myself right now.
No, no worries.
I mean, I like when we have fun, and I like when I screw up on things, but I don't like when I screw up to an extent like that. That to me,
all good.
I'm not happy with that.
Yeah, the viewers are coming back.
Yeah, they'll come back.
It's ramping up again.
Okay, yeah, these batteries are fitting in this tray really nice, by the way.
So you want to leave the space at the back?
Yeah, let's leave the space at the back.
Okay.
I'm actually very happy with the size of these batteries, more than online the specs read. I thought when my measurements, these actually seem to be smaller than the specs online, which is great. And you can see they fit perfectly in here. We have access to the control panels here, and in regards to seeing things, and also on the front of the batteries. I don't know if we never showed this, Michael. I don't know if we have a shot of that.
It's a wide shot, but yeah.
Down here on the batteries, this is where the COM ports are that we're going to use later on when we do some programming, so we can read the batteries directly. But in any case, yeah, guys, I feel a little embarrassed by what just happened.
It could happen to anybody.
But hey, that shows you the importance of why we taped it off to begin with.
Yes.
And what can go wrong. And the question I have right now in my head is why I don't have internet in my coach.
We'll figure that out later.
But we'll figure that out later. Brenda's no longer online.
I think she's online through.
She's online through the Southwoods RV Resort.
Yep.
But our coach internet is not where it should be right now. That's just kind of bugging me. So what I'm doing right now, guys, is gals and guys, people out there in the world, is we're just getting ready to connect these batteries up for the first time. And
well,
Michael, what did you want to do to this coach? Yes.
So yeah, let's see.
Which way did you want to run these cables, do you think?
Well, I just want to see if one is longer than the other without contacting them together.
You mean like somebody did?
So the black is longer. Okay, so we'll do black to that corner and red to this corner.
Okay.
Yep.
So that's where we're going to go. So we're going to start right here then. So now what we're doing is we have already pre-made these cables. And I got the wrong bend,
yeah,
I know.
You gotta flip over.
I got to flip it over, I know.
That's all good.
Just realized that.
So we intentionally made these just a little bit long so they'd have a curve to them so that we can still access these charge indicators here.
Yeah, without being able to do that, they would go right over to the top of them and we would not be able to access the little push buttons.
You gotta bend it a little bit more.
Couldn't see it. Okay.
Okay, let's slam them back. There we go. Okay, and before I sit this down, I'm going to bring this one in, and I'm going to bring it in that way.
Well, it would be me if I didn't drop or do something wrong during a live video.
That's all good.
Yeah, that's what people
Okay.
watch for. They're like, you know, did he live? Did he die?
What's going to blow up next?
Yeah, what's David going to blow up this time? I mean, I guess that's where it all comes from.
So you may be asking why we're picking specific corners to.
Oh
we
yeah,
don't
good
want that one
question,
yet.
Michael.
We'll
Oh,
put this
that's.
under it.
Oh, you want the black there?
Yeah.
Okay.
So let's get this one in first, though, actually, so that we have that down. So the objective is that you want the power to take every electron that flows through the batteries. You want to take the same length of wire, so the same resistance and the same path, to get from the battery it came out of and back to the battery going back in. So by taking the positive off of one corner and the negative off of the other corner, that means that no matter which battery is supplying the electron that's flowing out through the wires, in order to get back to its battery it came out of, it has to take the same amount of wire to get out and back, no matter which battery's there, or which battery it came from. Is this the size for that? Nope, that was too small. Is that the right size? Yes. Actually, David, let's do this a little different.
Okay. What do you want? What's your thought?
So I'm thinking something like this,
Okay.
and I'll let you fidget with that. And while you're doing that, I'm going to start tightening these down. And we're going to end up zip tying these here so that they come in and out of the battery, or with the battery tray. And there is a torque spec for these. I forgot to bring my torque wrench, so we're going to check that later.
Yep. I have my torque wrench also, and yes, we'll check that and put that correctly as we need to.
So that is the click. That'll work.
Oh, sorry. I'm right in a view.
Oh, actually,
Oh, you want it? Oh, you.
yeah, we'll get it down to that later. That's fine.
Well, let's do this. Let's bring this back here a little bit. And then we'll tie it to that one up there. So that it bends,
All right.
has a bend.
So, first, or next, I should say, let's adjust the charge profile of the
Oh, you still got somebody's message over there.
inverter. Oh, we have some messages up.
Yeah.
Why did you not put the whole battery hold down on before the connects? So luckily we have plenty of space here that we can put those bars underneath after. So we're going to do that off camera, basically. All right, so let's go to this view. And
Yep.
see here.
I'm gonna have to get closer than that.
Oh, closer than that. Okay. Can you see that? Maybe?
Yeah, probably.
All right, so we're going to go to, well, first the low battery cutoff out. We're going to crank that up. I'm just
Wait.
guessing at this point because we don't actually know the spec here, but we're going to hold it there for now. Battery type, we're going to change constant current, constant voltage. Max, we're going to crank that all the way up. It doesn't really matter because nothing here can supply that amount of voltage. Charge volts, we're going to turn up to 13 or 14.5, which is listed as the absorbed voltage. And we're going to end the charge based on how many amps is being taken by the battery. Each battery says it's done charging at 2 amps, but since we have 3 in parallel, then we multiply that number by 3 to go up to 6 amps. And we're not worried about how long it takes to charge them. And we're going to let it drop down to 13.8 volts before it tries to recharge. And charge rate. That's controlled there, good. Let's see, absorb time, again, constant current, or constant voltage, constant current controlled. And that's it. So we can go back to our meter, and right now we're at 14.1 volts. So I'm going to turn the charger on, and it's going to try to bring it up to 14.5. So here in just a second, you'll see this.
It might not, because I think you set it for 13.8 to recharge.
Yeah, but it says constant voltage, so it's trying to recharge right now.
Recharge.
Yeah, so this amperage should go up here in just a moment. It takes a moment before it starts spinning up. Got some schmoo on the screen.
At least of my worries right now.
Okay, well, take our word for it. Here in a minute,
It will spool up.
It'll start sending power to the battery.
So, where are we now? So now we are set at this particular point. Oh, we got a message still on the screen here. Will both legs
Of your 120 volt
be live?
So on the inverter output, the way these inverters are designed, yeah. So the way this inverter is designed, it actually has 2 legs pass through, and then when it kicks over to inverting mode, it disconnects the incoming 2 lines, connects the 2 outgoing lines together, and feeds those as a single 120 volt combined leg. So the 2 output lines from the inverter would be live just as if they always had been, the way Tiffin put it together. So none of that changes. The only thing that changed is we now have a much higher capacity battery pack that is much lighter.
Yeah. I went from, more or less, we went from the Lifeline batteries, which were 900 amp hours, usable as 450 because they were AGM batteries. We went to 600 amp hours of lithium ion batteries, which usable capacity is, 100% of that.
Yeah, so the reason why David said that 50% capacity on the AGMs and on the flooded lead acids are the same. Can you use 100% of the battery capacity on lead acids? Sure, if you want to. The problem is that it degrades the long-term life of the battery itself doing those deep discharges. So most lead acid battery manufacturers recommend a depth of discharge to 50% and then charge it back up. So lithium ions do not suffer that. They do have a...
it would probably help if we turn the house batteries back on.
Sure, why not?
It could be why it's not charging.
Little things.
Anyways, so I just thought about that we turned off the house batteries, which, by the way, just case in point, that issue that I had is because of how the Tiffin is wired.
Yes.
Because that voltage that took out the inverter to shut everything down is because that battery cutoff is just a battery cutoff.
For the coach.
For the coach. It does not, everything still goes to the inverter, and those are inverter lines. So them touching together, the inverter is still live. But we had the charger off and we had the inverter off. But the inverter still passes 120 volts.
Well, so it's passing 120 volts through to the coach.
Correct.
And it's passing some voltage here to monitor for the batteries to come back. And
it's watching for it.
Yeah, it was that voltage coming across the lines, even though the charger was off, that when it saw those 2 connect,
it said
that's a fault. I'm shutting
I'm going to shut
off.
down for safety. Yep. So we tested that. That. It worked well.
David's safe.
Yeah, everything worked like it was supposed to. So in any case, right now we have the house batteries turned back on, and the batteries are charging. They're currently sitting here at 14.1 volts, we'll see how things go. I mean, you're gonna make sure you set your inverter correctly in regards to your charging points based on the specs they give you from the manufacturer. And in this particular case, they're actually printed right on the battery, or you can request the full specs from the manufacturer themselves, and they'll send you that data.
Yeah, the only thing that isn't listed on the battery and that we're still waiting to get answered is the low battery cutoff.
Yeah.
We can speculate based on knowing that these are lithium iron phosphate prismatic cells. We can actually do the research online. Lithium iron phosphate chemistry for prismatic cells is fairly standard. The recommended voltage ranges for each cell is fairly well known. So we can make that educated guess, but we'd rather have the value directly from the manufacturer, which is, I think, basically one of the last things we're waiting for from them.
Correct. And once we have that, we'll just set that into the controller and we know we'll be good to go. And that point, the controller will just run everything from that point forward. The only thing I got to set is the gen set. So basically when the batteries get down to a certain voltage, the generator will automatically turn on to recharge the batteries when we're not on shore power, of course.
Yeah.
And because of it, because these are lithium ion batteries, they will take the full voltage, the full amperage of the generator that can provide charging the battery.
Inverter can provide.
Yeah, the inverter, yes.
Yes.
Well, the amperage of the generator is 70 amps. So
yeah, so two legs, 43 amps each.
Yep.
And then that comes into the inverter, but the inverter's charger, this particular DC charger, is only rated to 125 amps, if I remember correctly.
So that basically we will dump all we can as fast as we can into the batteries, thus cutting the amount of time the generator needs to run to get the batteries back to full charge.
Yeah.
So once we know that starting point, we'll set that, and then we'll also be able to set the auto gen start. So if the batteries get down to a certain point, it'll restart the generator. It'll start the generator, charge up for X amount of time or X amount of charge, and then shut the generator off, and we're back again on inverter power from the battery bank. But
so
overall, they charge a lot faster.
Yes.
Than thus using less diesel.
Gas. Diesel. Yeah, thank you.
Over time.
Gosh, it's been a long day.
Than it would for the AGM batteries or any flooded batteries, if you will.
Yeah. So for example, for mine, I had a 600 amp hour flooded lead acid from Tiffin, and my generator would have to run like 5.5, 6, 7 hours to recharge those. And that's, half of that is all that I would use. So 300 amp hours was all I was using and putting back in. To give you a comparison, my lithium ion battery pack is now 1,500 12 volt amp hours rated. And I can run the generator for 2.5 to 3 hours tops and be completely recharged on that 1,500 amp hours. So it's pretty substantial savings on the diesel side. One
of the best advantages to using lithium ion batteries. And cost, like I said, in this particular case, cost was, to me, was important. These are 200 amp hours each. They were $1,600 a piece, so basically $800 per 100 amp hours, but those are for heated batteries.
Yep.
There's a difference because
the non-heated
are less money normally than heated batteries, and these came in at a great price point and with great feature set. The app, I will say, I'm a little dismayed at. I'm going to say it. The app, you can pull up the app. It'll show you the charge volts on each battery, things like that. But you have to put in a password every time just to look at the cells.
Yeah.
And that's just
crazy.
It's frustrating every time. I want to look at 3 different battery packs. I got to put a password in every time just to look at the cell charge. And I don't know why. I have no idea why they did that.
Yeah.
But anyways, that's just hopefully something that LifeBlue will do in the future, and we'll go from there. But anyways, the batteries are now in.
We're running the coach.
We're running the coach at this point. Things are running as they seem to be.
Yep.
I guess we're good to go. Do we have any other questions online?
No, everything's good. Don't see any other questions here.
No questions. I'm surprised by that, especially after the blunder I made.
So I guess we'll sign off.
I guess that's it. So this is David Bott and Michael Kidd, and we
from Outside Our Bubble and turtleherding.com.
And we finally, Brendan and I finally have put in lithium-ion batteries. We chose LifeBlue as the manufacturer, heated version, 200 amp hours because 3 of them fit our tray, as you can see, perfectly, and
so 600 amp hours usable.
600 usable amp hours.
Yep.
So we're good to go. And because we opened up the battery, oops. We can tell you the build quality internally is
very good.
Very good compared to, we
Yeah.
didn't expect it. We really didn't.
Yeah.
For that price point, we never expected it to be built as well as it was.
Yeah, high quality wiring, high quality PCBs, conformal coating, so condensation,
Yep.
Moisture is not an issue. Yeah, really overall very well built.
Again, I'll say I paid for these batteries full price, did not get anything in return for any of this video, especially the,
Yep.
the shorting the battery.
You're seeing it
the shorting it.
as we are.
Yes. So this is it. This is you know how we are. We tell you like it is, and that's exactly what we're doing here. And we're not paid or any way, shape, or form to talk about this battery pack. It's just the one I happened to choose after doing research, and price point wise was something that was important to us. And I really needed to get batteries. I waited too long.
Yes.
So anyways, I'm David.
I'm Michael.
And we're going to leave you now as we tidy things up and put things away.
Yep.
Take care. Keep safe. See ya.
Bye-bye.